please welcome Stephen Goodwin.
Right, I'm on. Hey, thank you very much. So, as this part of the slide says, my name is Steve, and as that part says, I'm a little bit of a geek. Today we're going to be talking about digital archaeology, and as you can probably tell from my voice, I'm English. I'm from London, England, and I'm European, despite what the government says about me. So, digital archaeology is about preserving software, and that's what I'm going to be focusing on for the next 50 minutes. It's about the problems we have, the solutions, and a little bit of what we can do to prevent us having to go through this archaeological thing again in the future. So who am I and why do I deserve to be up here? I'm a geek. I got my first computer, well technically my parents got the first computer in 1983. It was a ZX81. My parents thought it would help with the homework. It didn't. They thought this new technology would give me something to talk about at school and it would make friends. I didn't make any friends. But I did learn how to program. And I did learn that I really like the old computers better than the new ones. And I'm still trying to hold on to that little piece of the past that says this old computer is better. Oh, and I'm also the founder of the Digital Heritage Archive, which is a pretentious way of saying I have a project on GitHub. So what is it we're trying to solve? What is the problem here? And if you want some little pithy one-liner to take away and tweet, this is probably the thing. It isn't that innovation didn't happen out throughout the 70s and the 80s. It's just that if we don't record it, we're not going to know. The Dark Ages were not an age where nothing happened. Hundreds and hundreds of years went through on the Dark Ages. Lots of stuff happened. But no one wrote it down. So we just assumed that nothing happened. So recording history is the important part here. And as we say, not just software, it's the data. I do some work at the Computer History Museum in Cambridge. And one of the exhibits that we have is a Mac that belonged to Douglas Adams. I'm pretty sure with this crowd you all know who Douglas Adams is. We have his Mac. We also had the hard drive that was with his Mac that had some of his unpublished writings on it. His family gave us the machine without realizing some of his work was on there. The people who own this stuff don't know what they've got and they don't know that it's important. So the obvious answer to all this is just, well, why don't you make a backup of it? Or as people of my generation think, we're making a backup. Who here is old enough to remember these Amstrad tape-to-tape machines? Oh, that's good. I thought I was the only one. So yeah, you can just make a copy of the tape, but after a while you need to refresh that. You know, how many people here still have a tape recorder? Even if we have the tapes, there's about 4 of us in the room that still have tape recorders. We need to refresh that. Take it from a tape, put it onto a disk. Take it from a floppy disk, put it onto a hard drive, put it onto a cloud network storage device. Backups are only valid if they're tested. Who here tests their backups? Not as many hands as there should be, but if you need to sysadmin, those people with their hands up, the conscientious ones, hire them. And yeah, issues with copyright, yeah, we're not going to do copyright, we don't like that. So, preservation. The first thing to preserve is the actual physical thing, the actual tape, the actual disk drive, the case and the inlay and anything that goes along with it. We'll come to why the bits that go along with it are important later, but for now we'll preserve everything. Or more technically, it's the archaeology thing. It's not the preservation, because we actually quite literally have to go digging for some of this stuff. The Spectrum, which is one of the most popular home computers in the UK throughout the 80s, had millions of pieces of software written for it. You'd think that, well, they must still exist somewhere. But if you go online, you'll still find there's an awful lot of this software which is missing in action. Someone wrote this, but no one knows where it is. There are no copies left. So once we've got our tape, how do we go about preserving that piece of software? Well, this is the tape. It'll probably jam. So you have to use, take it out of the case, put it into another case. It isn't just a case of slapping it in. Cassettes were recorded using generally 2 tones. They're 2 different beeps. A lot of people can probably remember the sound of their computer tapes. They probably played it through audio and it goes beep, 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 beep. All that's going on is there are just 2 tones there. In the case of the Spectrum, it's a 2047 Hz tone for a 0 and just under a kilohertz tone for a 1. As you can guess, it takes longer to store a whole tape of 0s than it does of 1s. And if your tape is slowing down or speeding up, then those pitches will not sound right. They might sound at 2050 Hz. The computer does have a little piece of code in it that says, I will accept plus or minus 5%. But if your tape is really old, which most of them are now, and it goes outside that bound, you can't load the tapes. So load them into Audacity or something like that, and fix it up manually if you are so inclined. That's the first reference for open source I've done so far. A pen and a tape, wiggle, wiggle, wiggle. If that doesn't fix it, you can modify the load and save routines. This is the bit which I mentioned, saying the computers have a plus or minus 5% tolerance, but if you're loading it into an emulator, say, or another piece of software, you can rewrite those load and save routines to accept a 10% tolerance, or a 20% tolerance, or modify them entirely just to get the program to load. Sometimes it's unfortunately necessary. It's dull and it's tedious work. The next problem on preservation is, well, how's it stored? We don't always use this 2047-1033 method. For things like copy protection, which you may be aware of, people decided they'd write their own load and save routines so that the normal load and save routines wouldn't work. So your standard disk copying programs and your standard tape copying programs would not work. So you have to work around them. Some people wrote fast loaders, custom loaders, and there was even a product which would let you load games off of a CD. You take the audio out of the CD drive, you'd stick it into your computer, and you would load it off the CD. Because the CD doesn't have this wow and flutter, and it doesn't vary the pitch at all, you can record at a much higher frequency, which means you can get a lot more data quicker. But trying to find machines of that era are quite difficult, so you have to keep the hardware as well. And if you do find a program that's using these fast loaders, you have to make a note of what it's using. Just as a by the way, I'm talking mostly about cassettes here, but this applies to any kind of medium. So, what computer is this tape for? It might say Spectrum, for example. Who had a Spectrum? Oh, not bad. Good. So you would write on it, this tape, which I've just now uncovered, runs on a Spectrum. Which Spectrum? How many Spectrums were there? Well, if you type in ZX Spectrum issue into Google, you don't need to be a computer historian to know there's more than one search result, and you don't need to be a hardware person to notice there's more than one circuit board. There are at least 13 SKUs in 8 distinct versions. I have seen numbers go as high as 25, so that includes things like the Spectrum Plus, the 128, the Plus 2, the black version of the Plus 2, and despite the color, it looks like there's only changing the case color. There isn't. They actually changed the whole circuit board. One of them works, the other one doesn't. Well done, Sinclair. And the 128 Plus 3. And these are just the main versions that most people have. The next part of the problem comes in processing that software, which basically means how are we actually going to load it in if we can't run it? Copy protection is a pain. Does anyone have this game? It's a trilogy of adventure games. Wow, there is. You finished? Oh, no one ever did. No one finished this one. But they had a really simple copy protection system. They made the manual so enormous that you needed the manual. You had to type in a word from page 26, row 3 on the manual to be able to get into the game. Photocopying an entire book was quite expensive. So naturally, not many people pirated it. But if you don't have that book, you can't play the game. Anyone have Elite for the Spectrum? Did you have the lens lock? Did the lens lock work? Yeah. This device here, this is called lens lock, and it is a diffraction grating, which is a posh name for a piece of plastic that wobbles images about, and you put it onto your screen. And a piece of the screen image from over here appears on this side of your vision, and vice versa. So the screen displays a wobbly, weird graphic. You put this thing on the screen, and it shows you another weird, wobbly graphic because your TV is the wrong size. People got paid money to develop that. So it didn't work on the TVs at the time, it certainly doesn't work on them now, and it doesn't generally work on LCDs either. Nice one, guys. Monkey Island, a much more recent game? Yes, yes. Pretty much everyone, good. You had this little dial of pirate wheel, and you know, the screen would say now turn the pirate wheel to this and that, and you could play the game. If you've lost this, you can no longer play the game. Which, by the way, this face here, I did this talk in Cambridge a while back, and someone pointed out, that looks like Donald Trump. I thought, yeah, but there is one difference. Donald Trump and a pirate. No, people aspire to be a pirate. Ooh, okay. And Jet Set Willy. This was the copy. If you didn't like the idea of photocopying in time manual, you certainly wouldn't be able to color photocopy this thing. You could do. It would be expensive. And some people would spend their maths lessons writing out this chart by writing RBBB, YYYB, and so on. I'm not saying I did that. I'm just saying some people in maths lessons would copy this chart. No, luckily nowadays, this thing is available online, so you can actually try and get into Jet Set Willy with this copy protection system. But for a long time, you couldn't. These pieces of card were not given away, that you couldn't buy them. If you wrote to software projects and said, I'm sorry, I've lost my card, will you send me another one? They would say no. So for a long time, Jet Set Willy was lost, even though it's one of the most popular games, just because the pieces of cardboard weren't available. Some other software would have dongles and other things to protect it, especially the more expensive things, which again will get lost. So the solution is emulation. Well, one of the solutions is emulation. My favorite solution, that is. Open source projects abound here. MAME supports computers as well as games consoles. Big project. VirtualBox, because we can't escape Windows, no matter how much we might try. It's also important because we can't escape older versions of operating systems as well, and this is an easy way to do it. Even open source software from years ago, there was a lot of emulators written, which are now defunct, because they only worked on this version of DOS or that version of Windows. And it's an unfortunate state of affairs, but emulators are one of the few pieces of software which actually can get finished. Every piece of software you work on is either out of date and needs updating or needs fixing or whatever, or it's redundant because we don't use that anymore, we use something new. The ZX Spectrum for the 1982 release is the same Spectrum it is now. So you can actually write an emulator and say, the emulator is finished. Which is fine, but it means it suffers bog standard bit rot. Someone releases it onto their website, they say, there you go, the emulator is done, it's finished, I don't need to touch it. And 20 years later, you suddenly realize that you can't run it anymore because that version of Windows is not available. You have to then run it under an emulator. So you're running an emulator on an emulator. If you want to do this whole down the rabbit hole thing, again, a thing in Cambridge, there was a ZX81 emulator running on a Dragon emulator, which was running on an Amiga, which was running on a virtualized Mac. Which was, a pointless exercise if ever there was one. But the fact that you can still keep that old machine alive by successive emulation is a sign that maybe we can retain some of that past. Zeta FM, the VM, sorry, this is one I heard about last year. I've not properly looked at it. It's a virtual machine for dynamic languages, which might be thinking, well, why can't the dynamic language actually be the language of the chip or the machine? There's a possibility there. Emulates is one of my little things. It's just I have it basically to talk about emulation. And one of the things on there is describing the chip as an XML file, describing it as a process. So then you run the XML through a process, and it spits out the emulator code. At the moment, it's an idea. Maybe it'll work. And the tip at the bottom, which you've all read by now, look for machine-specific things. JSPECY, as the name might suggest, is a JavaScript emulator for the Spectrum. The guy that wrote that knows a stupid amount on the Spectrum, much more than the guys that write MAME. So if anyone can make it work on JavaScript, it's Matt, and because he knows that stuff, that emulator is better than the others. So always go for a specialist thing if you can. So thinking badly about copy protection, there was one system that had perfect copy protection. It's that. The games were so bad, no one could be bothered to copy it. And in fact, on some of these, you can see it was written for the BBC, Dragon, Spectrum, Apple, Atari, ORIC 1, the ZX81 and VIC-20. On a couple of those machines, notably the Dragon, they didn't even bother testing the final tape because no one had noticed the last two games on there were recorded onto the lead-out tape, and therefore you couldn't actually play them. I have no idea where they've gone. And that's it, we're done. We can now preserve all of our old tapes, all of our old discs, and keep them for the next generation. Because I quite like the idea that in the future, I will be able to share what I grew up with the next generation. I think that would be quite nice. But, we can't do it. We've got to document everything. We've got to document the program, the machine it's for, which version of that machine, how to how to legitimately use the copy protection, and store it somewhere. One of the bigger problems, because it's a community, and communities have ego problems, a number of retro sites over the last few years have been having a lot of problems and a lot of infighting. There were archives which had all of the software on. Everyone they would take their tape, they would sample it in, they would fix it up, they would send it to the archive would keep it. Fantastic. Then the owner of the archive gets a little bit narked at someone else that's running the archive, and they shut the site down and take all the software, and it's all disappeared. Archive.org does not help with this, unfortunately, because it preserves the pages, not the zip files with the programs in. So if it can be held somewhere like GitHub as an example, which is a little more public, it's still an as-a-service provider, but making it available so people can take it and fork it and preserve it themselves is a good thing. That one, which is the thing I'm messing around with at the moment, this is just basically an archive of metadata, and it's only in the request for comment stage right now. It's a case of saying, if you want to preserve information about the machine, its social impact, your relationship to it, is this format a good way of doing it? So if you get bored, have a look and send me comments. So to recap on the solutions, and this is the TLDR version of the talk, examine the audio structure, look at it, break it apart, work out how you need to load it back in, and document what it is. Document the loading method. So some computers, again, I'm going to mention the Dragon 32, there was a different command for loading BASIC to loading machine code. If you were working on the Dragon at that time, you would naturally, instinctively know whether it was BASIC or machine code. Coming back to it after 30 years, you probably don't. So you need to make a note of, well, how do you load this? The Jupyter Ace used forth. This would sometimes require you to load a bit of a program in, define a dictionary method, and then use that to load the next bit of the program in. It's not obvious by looking at it how you need to load that. So that needs to be all documented. Next, learn the copy protection system. Emulators are always good for this. That screen is, I think, Manic Miner, could be Jet Set. Archive those recordings, not in MP3 because it's lossy. We want proper lossless stuff because the disk space is cheap. And this starts, actually I'll go on to the next one. So just archive properly and document it all. Make sure everything's known. Lego. In every talk I do, I manage to get something in Lego and always have a beer. So I've got my 2 touchstones down now. So document what the software is, what version it is, how it needs to be loaded. Store in something such as Git so it can be available. That's trying to avoid infighting and communities. And store everything. Again, grab websites occasionally. I mirror far too much for my own good. If you can get original documents, obviously. And latest is not always greatest. This one I put in because I was doing, I was doing some archive work on a machine, and I managed to load the tape into the machine. It sampled well. I managed to process it and store it as a snapshot. I needed to go back and do some other things, so I got the latest version of that software, and it no longer worked. Apparently, people add bugs into software. Who knew? So keep a track of everything. So when you say, I'm loading this game into this machine, you're saying, well, I'm loading this game using this version of the software into this version of the emulator, because the newer versions might not work. Everything needs to be refreshed. The same way that you need to refresh the backups as you move from tape to disk to cloud, you need to refresh everything itself. And this, as you say, includes the emulators. There are currently, as far as I can tell, 3 emulators for a computer called the Elliot. Now, the Elliot was a machine in the 1960s. There were about 1,000 were made. I think there were 10 working left on the planet. We have one in Cambridge. I'm not allowed to play with it because it's quite brittle. But there are 3 emulators, so I can use the emulators. One is written in Ada, which I don't know, and all the Ada programmers are in the Ada room, which is always full, so I can't ask them how that emulator works. The other one is written in F#. Who here has used F#? There are actually hands for that. I thought there was going to be no one. Okay, so you can help with the emulator. I didn't realize, I've looked at F#, and it's like, okay, I get it, but developing for F# nowadays is a little bit tricky. It's not really supported. It's a Microsoft platform. It seems to have been mostly dead. So again, you need an emulator to bring up an old version of Windows with an old version of a dev environment to actually run through F#. Because a lot of the complications in an emulator is not the instruction set, it's the minutiae. Those little bits, those little timing things, the odd bits, the bugs in the hardware that the emulator has to reproduce. If the code is in a language you don't understand, or it's tricky, or is obsolete, you don't get that nuance. So the new version of emulators are not as good. Which brings me to emulator number 3, which is in JavaScript, which I wrote on the Eurostar over here, and is very bare bones, but at least it's JavaScript, so at least I can understand it. Oh, and document everything. Exploring the tools. There were often tools that come along with the emulators. So going back to the tape, which uses the 2 frequencies, beep, beep, there were often tools that will take in a tape where the frequencies vary outside that plus or minus 5%. They'll sample it in, they'll fix that plus or minus 5%, and then they'll write out a new tape, which is perfect. Write it out as a WAV file, which you can then record. There were a lot of tools like that which help. Again, the version of it will vary. Sometimes the version will break. So having every version necessary, documenting which version is used to fix up which tape. And how to run the tools as well. Tools are there as tools. They are there to do a job, and often that job is restore one piece of software once. And that's fine. But it does mean that the second person that needs to come along has no documentation and they don't know how to run that tool. And documenting the source chain. So by that, it's very good that we've got a tape here which says, this is Jet Set Willy for the 48K Spectrum. It's very good that it says, this is how you must load it. It's very good there's documentation that says, here, this is the copy protection system. But if you don't have another document that says how all these things are joined up, you won't be able to put the bits together. So the whole source chain needs to be documented and noted. And that's kind of one of the things I'm hoping that the archive will do, preserving people's knowledge. Future. So that's it. We can store all this, and the future's going to be absolutely perfect. Now we know what to do to preserve old software. All the current stuff will be preserved going forward. Excellent. All you need to do on this computer is plug a USB in. Which one? This isn't even a full set. This is what I had beside my desk when I thought about taking this picture. I know there's a lot more, but these are the ones that I have, and I'm not, I don't have a lot of kit. So even going forward, we need to make a lot more notes about what we're actually doing. So the future's going to be imperfect. Maybe we can't rebuild the emulators quick enough. Maybe we can't build the software quick enough. Maybe we can't write enough documentation. If you're having a little chat with someone about building something, and you're doing it in Slack, for example, that's transient. Come next week, you might not be able to scroll back far enough. Slack might go under, get bought or something, and all that information is going to get lost. Writers from the sort of 1800s, 1900s, and even 20th century wrote on things called paper, using things called pens and pencils. When they die, people are actually able to go into their loft, find the boxes of all these papers, read the diaries, and learn how that author got to where they got to. Look at their notes for characters, see how their plotting developed. We can't do that. In 100 years' time, no one's going to go back and say, let's look at the Slack channel. Let's see how they came up with this idea for software. Let's see what they did. We won't be able to. It'll be in emails. It'll be locked out by passwords. So we've got to bear that in mind. And we don't own our data anymore, as much as we like to think we do. So, another problem we're going to have, and I'm guilty of this as well, things that are done on the web. We're going to be losing most of that as well. If you ever remember sites that says, this website works best in Navigator. This page has been designed for IE6. All those sort of things. Sometimes it's merciful that they're gone. But for a historical point of view, understanding the social impact that each of these things had, it will be lost. Any old web games, Flash games. Flash, yeah, great that it's dying, great HTML5 standard, great that it's taking off. Not so great, but there were a load of Flash games that people of a generation younger than I grew up on. I wrote some of them. Online games, I wrote some of them too, but they're also going to die. I mean, Blizzard, now World of Warcraft. Even Blizzard cannot rerun the very first version of World of Warcraft because the servers have changed so much, the clients have changed so much, that it's not possible to play that original version. So if you want to see what got people hooked on World of Warcraft by playing that first version, you can't. It's a cultural and gaming phenomenon which you can't play. Some people tried rebuilding some of the Blizzard servers in BNetD, and Blizzard go, we don't like that, and they took them to court and shut them down. So the one hope we had of keeping some stuff alive, you can't. And for a previous company, I worked for a company called Playfish, which built, unfortunately, games on Facebook. So they were Flash games on the web, online, as a service, gaming as a service. You would buy little things in the game. Few companies, we had 10 million people a day, every day, playing some of my games. That was fantastic. Except now they're all gone. Because it's Facebook service, that's gone. The company's gone. The Flash backend servers, which was written in Java, they're all gone. Even if you happen to have saved some of the Flash files that were downloaded, you only downloaded the files you needed. So you probably wouldn't be able to play it again, even if you rebuilt the server. So I, as anyone, am guilty of building stuff that has built-in obsolescence, which is a shame. That's gone. The games that people enjoyed playing, 10 million people a day, will at some point look back and saying, I remember playing Pet Society, that was great fun. Wish I could show the kids, but I can't. So conclusion-y type, multiple stages of preserving the stuff. First is the physical medium, and this is the TLDR version of the TLDR bit I just did. So we start with the physical medium, preserving that stuff, sometimes taking the tapes out, putting them into new casings, finding a way of archiving that in a good, stable format, WAV files, lossless files, preserving the data itself, saying what is it that I'm preserving here, how it needs to be processed by the machine, how it's loaded in. Do you load it as basic, load it as machine code? Do you process it in some ways, there's a copy protection on it? And then for the future, storing it in a way that someone cannot take offline. Which pretty much comes to the end and opportunity for questions. Some links there. Oh, I should update my scorecard. There we go. So yeah, I think I've got time for questions. No one's put up signs. Yes, I've got time for questions. I've got lots of time for questions. Wow. 20 minutes. Do we have 20 minutes worth of questions? Because I do stuff at the Computer Museum in Cambridge, as I said, and although I do preserve some bits of hardware and some bits of software there, a lot of my time is spent talking to human beings about the computers and why they're important. So I can talk quite literally for hours. So we've got a question here.
Okay, I have about 5 boxes of 3.5-inch floppy disks from my old Atari ST, but my STs don't work anymore, and I don't have any other floppy drives. So could you recommend what the best way of transferring them to something stable is?
Right, so the question is about getting floppy disks actually into an archivable format when you don't actually have a working floppy disk drive. And in the case of floppy disks, it's one of those cases where you just need to find another floppy disk. A lot of people, because people are now of the age where what we had as a kid, we are able to rebuild ourselves as grown-ups. I use the word grown-up in the loosest sense. It doesn't apply to me. Well, it might grow. My teddy bear says I'm grown up, so that's good enough. But what people are doing is they're taking the disk drive interface, feeding it to hardware like Arduinos and Raspberry Pis, and then getting that to be a disk controller. It's a virtualized disk controller, and that then goes into a Raspberry Pi or an Arduino, which can then go into a solid-state memory. And there are a lot of devices out there, especially for the more popular machines, Spectrum covered all this, probably one for the Atari, where you plug that in, and the Spectrum looks at it and goes, oh, right, I know this. But the hardware is tricking it, and it's actually loading stuff off of SSD. One of the things we have at the museum is a Spectrum with this SD card in it, so you can play 1,000 games off of an old Spectrum without wearing out tapes, without wearing out the disk drives. So you may be able to get one of those units to rip the stuff off. I mean, there was a lot of software at the time, things like CrossDOS for the Amiga, which would allow the Amiga's disk drive to read a PC disk format. And that is one way you can do it. You'll often find those sort of pieces of software. There's a question over here.
Yes, I find it peculiar that you don't mention more ephemeral means of archiving the context. For example, taking a video of the working system. It's not a real backup, but it can be preserved much more easily, and it shows something that the other things that you mentioned really don't capture the feeling of it.
Yes, if recording videos of the old machines in situ is a fantastic resource. And yes, we can stick things on YouTube and use that. It's a lot more work, but that's fine. I like the videos, they're great. The only thing they don't give me is the opportunity to play with it. Computers are an interactive thing, and especially for games, which is a lot of my background, I like being able to say, yeah, but what happens if you do that? What if I did this instead of what that person on the video did? So I like videos, but if it's possible to have it working for reals, that's even better. Another question on this side, is that? I know it's a question on that side, middle.
Do you test your documentation, for example, by giving it to someone who doesn't know anything about the technology?
So would I leave documentation to someone that doesn't know about technology?
Yeah, how you test your documentation?
Documentation for me is, when it's good, it's great. When it's bad, it's better than nothing. So even if they don't know a lot about the tech, at least having something, it means that someone that is better at writing, perhaps, could take it and massage it into something that's some readable prose, or they could massage that into something that's more technical. Because the hardest part in a lot of things, documentation, everything else, is about getting started. So if anyone, even if they're not technical, getting something started is a plus point. Is there questions?
Thank you for your speech. One question, it's more a comment. It's not only about game and software, but for example, in 30 years from now, you will not be able to have something called a classic car that is built today because you will not have software to run it.
I didn't get all that, so in the future we're not going to have any software to run any of these things, you reckon?
No, for example, if you take a car that is built today, and in 30 years from now, all the computers that is inside the car, you will not be able to build it again, so you don't have a working car anymore. And it's also true for every consumer goods that we can have today, and that is embedding some software. So for this digital heritage, it's not only about game and software, it's about almost everything today.
Yeah. Yeah, I could do a whole nother talk on what we do going forward, machines in cars and all this kind of stuff. At the moment, I don't know how we're going to preserve that stuff. I'll leave that to someone smarter, possibly. Or I'll come back in 20 years and tell you how we did it then. There's a microphone there.
Hi. A few years ago, I was working in a library to do the IT there, and to my amazement, none of my 9 colleagues who had master's degrees in librarianship and archiving knew even the least bit about what a database was or how to archive anything that wasn't paper or parchment. So I was wondering, is this like a hole in the Belgian system, or do you also notice the same lack of knowledge about with actual library professionals about archiving anything that's produced later than 1955? Do you notice that? Is that a worldwide phenomenon? Is there something missing here? What should we do?
I think it's similar. So the question is about professional librarians not knowing how to archive modern things, such as this. And it does seem to be true. I went to the British Library a couple of years ago, not to borrow a book, but to talk to them guys about this stuff. And they've got a project where they're doing emulation as a service with a university in Germany. And it's new to them. And it's like, this is the British Library. This library is basically our modern Alexandria. But they're librarians, they're not tech people. And the same way it was earlier on this stage where the MEP was saying about politicians and tech people are not really having that dialogue. Librarians and tech people also are not having that dialogue. And it's the same problem. I call it the information dissemination problem. It's very easy a lot of the time. You have a lawnmower to sell, I want to buy a lawnmower, you both go to eBay, you do the lawnmower. Simples. If I have a piece of knowledge which is useful to you, and you need some knowledge from me, how do I know who you are? How do I know how to get that information to you? If you are sort of working in a school, for example, or a library, and it's like, right, I know how this library needs to store this information. How do I get it? How do I know that person exists? How do I get to that person? If I call up or email, I'm going to get the receptionist. The receptionist goes, it's another time waster trying to sell stuff. So there isn't an easy answer on how do you get that information to the person that needs it. And it's an ongoing problem. So, but hopefully some people will see and they'll put the two and two together and say, actually, I know this librarian, they should go and talk to Steve, and then he'll sort of help them, and then Steve will put them in touch with someone else. So hopefully something will happen, but it's still unsolved.
Hi. Hi, Steve. Hi.
Oh,
is there time for one more question? One more point. You said it's very important to keep the original documents. If we look at the first talk in this series, the original Unix, the archetypal ancient Unix in the PP7 was lost until someone found a printout and retyped the characters back in. I used to work in X-ray imaging in a hospital, and someone pointed out to me that film X-rays are outdated and expensive, but they act both as an acquisition medium, they act as a medium for storing the images long term, and also for reviewing them. And all you need is a light source to look through a film. And the same goes for analog photography printed out on photographic paper. We say that's very outdated these days. We poop it. We've all got phones. We've all got Google albums on the web. But if you keep analog photographs in a box, in 20 years' time, if it doesn't get damp, you can bring it out, and all you need is a light to be able to view it. You don't need something digital. So I don't know what you.
Digital formats are kind of bad in being preserved, because they will rot in the digital sense. You've actually reminded me of 2 points which I should probably go over here for. This is what my university lecturer called a mid-lecture activity. You go to the other side of the stage and you do sort of a complete break. You've reminded me of 2 bits. One of them is that computers and software is a bit like episodes of Doctor Who. We all know Doctor Who in its modern form, not mostly I've said, but there are episodes of Doctor Who that, despite being one of those popular sci-fi shows of 50 years, that are lost. How does something which is that popular have episodes which have been lost, and lost forever? This is the BBC. They recorded them, they broadcast them, they thought, no one's ever going to want to see this again. It's a piece of cultural history, and they junked it because of fire regulations. The Spectrum, as we said, has millions of pieces of software for it, but some of them are missing. Why are they missing? They just are. There's a deep parallel there. So trying to recover that, yes, you could print everything out, and then you'd be able to view it using only light. But this stuff is going to get lost. You had a question, I think. No, Hello.
Hello. Hi. So we talk a lot about emulators for computers from the 80s and 90s. What work is actually being done now, and is it even possible to build an emulator, for example, for the latest Xbox or the PlayStation 4? Will we still be able to use this tool in the future?
Good question. And obviously when someone says good question, it's like, this is something I wanted to talk about but didn't get around to. Is it possible to build emulators for example, PlayStation 4? And the answer is not easily and not now. I wrote a series of games for the original Xbox and the original PlayStation, and I'm allowed to tell you that. But I'm not allowed to tell you how I did it. All the documentations for all of those consoles are under NDA. We're not even allowed to take the machines out of the office that we had them in. So if you want to build an emulator for that, you can now go online, because some people have leaked the specs. But for most of those machines, especially the newer ones, which are still under NDA, which are still being fiercely protected, you can't even read the API that you need to program these things, let alone see what silicon is being used. And that is going to be a problem. You're going to just have to keep the hardware alive, because you won't be able to build it in software. My guess is maybe 10 years, PS4 specs will get leaked, the APIs will be available, and emulators will start getting written. The technicality of writing an emulator is not difficult. The difficulty is getting that knowledge and getting the knowledge which hasn't been written down by someone. Those little bits, those bugs which no one noticed, the things that only the operators that spent day in, day out on them would know. Here's a machine that doesn't work, kick it here. That sort of little bit of knowledge which is being passed down person to person vocally, that stuff's getting lost. But hopefully, the archive project up there, that's just a dumping ground where I'm hoping people will simulate things like serial numbers for their machines and, their memories of the things, so bits don't get lost. And hopefully, that will be PlayStation 4, give it a while.
Okay, I'm Basil Stankiewicz, okay? I have a question to you. My father wrote probably the first commercial compiler in 1959, the year I was born, okay, in France. I have a report in French about that drum machine at home. But my father wrote it, so I don't want to put it in the garbage, okay? It's emotionally important to me. I'm happy to give it anywhere if it is useful, but I don't know where. I'm happy even to scan it, but it's not that easy and so on. What kind of concrete advice could you give me? And I can also add that as a teenager, I worked on that 1959 machine in a museum at Palais de la Découverte in 1974. So I have some remembrance of it. What can I do of it?
So what you can do with old machines, old documentation, is find a computer museum. And there's not that many, unfortunately, but they're, especially the one that I'm involved in, always happy to take stuff. There's two lots of reasons we take stuff. One is it's important, and it gets archived and it gets documented. No. Proper museums which are properly run, everything is file stamped, ranked, briefed, debriefed, and numbered. So we know everything. We have a history of. So when someone donates to the museum, fine. Just because something is in French doesn't mean it's any less important to the history of computers. That wasn't meant to be a joke, but it was serious. I am occasionally serious. So yes, find a museum. If not, Cambridge and that is happy. I'm sure there's one here somewhere. But my French is bad. I'm useless at French, so I wouldn't know where. You know of a French museum?
There is a museum, a new museum in Namur. It's MIP on the internet.
Give the mic. M-I-M-P, is that?
Yes, there is a museum, a computer museum in Belgium, in Namur, and it's, look on the internet, it's NAM/IP, or minus IP.
Excellent, thank you.
Yeah.
NAM, that's where you need to go.
One more question.
It's been useful.
Yeah, if you let me.
No, this is, I think we switched to another. It's more a command, because I think most of what you said applies to hardware too, and not only to software, because for those old computers there were extension cartridges and whatnot, and even reverse engineering the chips in the computer is super important now, because it helps improve us to do the emulators or even rebuild the machines with the means of FPGAs or something like this. So, and I think your principles can be applied for hardware as well, right?
Absolutely. Everything I've said about software applies to hardware. The difference being hardware is a slightly different skill set. I mean, computers from 10 years ago, you need to replace the capacitors, essentially, but also chips. A lot of people who are in sort of Facebook groups about repairing the old BBC micros or whatever, they will talk about, yes, well, this chip's not available, but this is an equivalent for nowadays. Or this thing you can't get, so you need to use this instead. The knowledge is out there, it's just about getting everyone to share it. As we've already seen, one chap asks, I want a museum to give this to. Another chap says, well, this is the museum to give it to. Just creating that forum, I think, is at least a start. You have a microphone?
I have a microphone, and it's great. Finally, I can make a short notice and ask a short question. Oh, thank you. First of all, I would like to mention that taking into account the really small memory footprint and small consumption of computer power from the contemporary point of view, there is some practical sense to treat emulated software, ancient software, as not as emulator at all, but as some very specific type of multimedia document. If you can use your virtualized operating systems from 1980s, for example, or even more earlier times, as a very special multimedia, image, or almost image, and embed it into some documents, then, at least it can be easily implemented in practice, taking into account that, at least HTML5 documents with some embedded JavaScript and so on, allows us to do it, and it may be a little bit more comfortable approach than running emulators separately. And the short question is whether you have some learning courses targeted at, well, studying this ancient software or anything like this currently? Are there anything?
Do I have any courses, was that?
Yeah, some university courses or anything like this. Do students have some courses related to ancient software?
I don't know of any courses that are specific about either emulation or archiving of things. I don't know if that's an intentional decision, because who on earth would want to do this stuff, or whether it's just a case of it's actually quite new. Previously, not many people have considered the idea of preserving an old computer or an old piece of software. Why would they? Computers, you want the new, you want the shiny. But from my point of view, from a cultural thing, everyone uses computers now, whereas everyone used to read books. So computers are our modern day tool. So they should be preserved, but no one has probably got round to realizing there needs to be a course to teach it yet. So everything is basically trial and error right now. I'm learning this, when I was mentioning actually with you earlier about the British Library. They're learning stuff from me, I'm learning from them. They have a thing, it's not about preserving this machine for the next 5 years, or meaning I can preserve it long enough to get the data off it. They're looking at 50 to 100 to 500 years of preservation. And that's an order of magnitude beyond what we're generally trying to think of when we just think, I just need the machine to work a little bit longer. Please don't crash until I've saved this, that kind of thing. So maybe at some point there'll be courses, but I don't know of any just yet.
Well, for the hardware, you could write, like you said, an emulator that's finished, but how will you ever know? You always have problems like a transistor is too close to another transistor, and you never see any strange thing, so you think, I emulated hardware perfectly, but you didn't. And then if the emulator code is used a couple of years later for yet another medium, this effect will only grow and grow and grow, and give it 20 years, and it will do something completely different to software on the hardware. You will still think that the emulation is perfect, but I assume it will never be correct.
Yes, so the question evolves around emulation is never going to be perfect, and it's actually kind of right. The simplified emulators are perfect enough, but there are two words in this community. There's emulation and there's simulation. What I call an emulator is technically a simulator. It isn't doing what the actual hardware ever did. It's just pretending to be that. And that's kind of a problem, because, as you say, a couple of transistors will interact. You might get things like ground bounce, where if you get enough current going through the emitters part of your circuit, it raises the value of ground. Well, if it raises the value of ground, transistors and other things start switching to unknown states. None of these emulators really do that. Mine certainly don't. So they're always going to be imperfect. And as you refresh each cycle, as you take the F# emulator and redo it in JavaScript, some of these bits that they thought of first time round will get lost. And over time, like the whole Chinese whispers thing, you start off with one machine and you end up with something that isn't quite that machine again. And unfortunately, I don't have a good solution for that yet. Other than running emulators on emulators, you can simulate things at the hardware level, but it's a lot more complex and it's a lot more than people want to do. It's generally easier to maintain the physical hardware.
So we've got time for one more question. Okay, no more.
There was one here on the end.
One last question.
Hello. Oh. Hey, so regarding your last comment about maintaining hardware, do you think it makes sense to maintain kind of have obligatory to send a copy of that hardware and to be stored somewhere, for example, by your project, and kind of have it somewhere and keep it for relevant for the next generations, let's say?
Keeping hardware relevant?
Yeah, basically the rule which is applied to books and newspaper, which is obligatory to send one copy or more copies to the National Library and keeping them there and so on and so forth.
Yeah, so if newspapers going online means that they're not being archived the way that paper was. And the British Library is certainly trying to do things of that ilk. I'm not involved with them in doing that, I just chat to them occasionally. So they do have a remit where they can take copies of the websites for the news stories of the day and the comments to get a feel for how the public reacted at this point. Because that's the sort of thing future historians will look back on. But there isn't a good way of doing that. You know, you can screen scrape, but we've probably all written a screen scraper at some point. Someone changes their website, you can't archive that information anymore. Yeah, it would be nice. So about what if a company supplied its hardware to the British Library in the same way that newspapers supply newspapers and books to the British Library? And I agree, I would love that. Sony would not like that. They would say, this is my proprietary information, this is copyright, this is NDA. Unfortunately, I don't agree with them. You know, if you want to be able to maintain it, if you buy something and you truly want to own that thing, not knowing what's inside it, not having a schematic, I think is a hindrance to that. All the old computers, and by old I mean good computers, they had a schematic in the back. There was a circuit diagram. That's fantastic. I never used the circuit diagram, but I like the fact it was there. Modern machines don't do that. I would like if they did, but I don't know if I'm a pessimist or a realist when I say I don't expect Sony or Microsoft or Nintendo to go along with that. And certainly not to the detail that would be necessary to build an emulator or to maintain it. They'll have, here is a chip. I'm not telling you what's inside it. I'm not telling you how it works. I'm not telling you the inputs versus the outputs. I'm just saying, here is a chip. We manufacture it. We're not saying any more than that. But I was hoping to end on a positive note, and I've just said the future is damned. But the future's going to be great because we can now preserve it and we'll be able to play Jet Set Willy forever, which is basically how long it takes to play that game. Thank you, good night.